topic for today is EI-232 or RS-232 serial I/O standard. The RS-232 revised standard 232, now known as EI-232, is a standard for serial binary data interconnection between data terminal equipment, that is DTE, such as computer or a terminal, and a data communication equipment DCE, such as a modem or a router. The Electronics Industries Association EIA established the standard in 1960, and after various revisions it came to be generally known as RS-232C. In today's video we'll be discussing the RS-232 serial I/O standard. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you get notifications for our future videos. The topic for today is EI-232 serial I/O standard or RS-232 serial I/O standard. Now we'll begin with the basics of data communication. Computers, they transfer the data in two ways. First is the parallel, where normally 8 or more lines are used to transfer data to a device, but the distance will be very small, few feet. So here you can see this is the sender, this is the receiver, and the number of conductors. In this case we have shown 8 conductors. They are connected from sender to the receiver. That's why the distance is less, because we have to connect number of conductors here. Then in case of serial, here we are transferring the data from sender to receiver 1 bit at a time. That's why it is called as the serial transfer. So here only one wire or conductor will be used. That's why the distance can be moved. Then let us go further. Types of serial communication. Now serial data communication, it uses two methods. Synchronous method, that is transfers a block of data at a time. A block of data means there will be say 256 bytes or 512 bytes or 1024 bytes, so on. Whereas in asynchronous method, it transfers a single byte at a time. Single byte means just 8 bits at a time. Then for the transfer of these special ICs made by various manufacturers for serial communication, they are being used. So UART, Universal Asynchronous Receive Transmitter, that is one such type of IC, and USART, Universal Synchronous Asynchronous Receive Transmitter. The 8251 is example of USART, and 8250 is example of Universal Synchronous Receiver Transmitter. And most of the microcontrollers, the UART and USART, they are present. In PIC 18, these are present. We'll be studying that with respect to PIC 18. Then protocol, start and stop bit. Now here we must understand what is protocol. A protocol is a set of rules agreed by both the sender and receivers on how data is packed. That is the framing of the data. Then how many bits constitute a character, whether we are using 8 bits or 7 bits or 9 bits for making a character. Then when the data begins and ends, where is the start and where is the end. So these things set of rules defining these things is called as a protocol. Then asynchronous serial data communication is widely used for character oriented transmissions. So each character is placed in between the start and stop bits, and this is known as the framing. When we make a character and add start and stop bit, we call it as the framing. Then block oriented data transfers are synchronous methods. Now start bit is always 1 bit, but stop bit can be 1 or 2 bits. Start bit is always 0 or low, whereas the stop bit is 1 or high. Here the stop bits, they are variable, that's why we are taken as stop bits. It can be 1, 1.5 or 2 bits. Let us go further. The framing or in asynchronous, you can see here in this figure ASCII character A. Now the binary value for ASCII character A is 41. Here it is shown 01000000 41. So when we are framing, we start with the start bit. Now start bit, it is low, so it will go out first, and then we have the data bits D0 to D7. So these are the data bits, and then we have the stop bit. Here you must understand, a 0 low is referred to as space and high is referred to as mark. This is mark and this is space. The transmission begins with the start bit followed by D0, then that is the LSB, and then we have the D1, D2, D3, D4, D5 and D7, like that. So here we have, this is the LSB and the MSB is this. So 0 1 0 0, that is 4, then 0 0 0 1, that is 1. So this is how the ASCII character will be framed, and there is, we are adding the start bit and the stop bit. Here there is a single start bit and single stop bit. Then let us go further. Data transfer rate. The data of transfer in serial data communication is stated in bits per second, BPS. And another widely used is the baud rate in modern terminology, and is defined as the number of signal changes per second. In modem, there are occasions when a single change of single transfer several bits of data. So in case of modem, the baud rate is important, whereas for a conductor, baud rate and the BPS, they are same. So let us now begin with the introduction to RS-232. So RS-232, revised standard 232. Now it is known as the RS-EIA 232. So it is a standard for serial binary data interconnection between the DT and the DC. So DT means data terminal equipment. Here computer or a terminal, these are the data terminal equipment, whereas the modem or a router, they are the data communication equipment. So the EI, that is the Electronics Industry Association, established standard in 1960, and then the modifications were done on these standards. In 1963 came the RS-232A. and in 1965 came RS-232B and 1969 RS-232. So presently it is called as the RS-232C. Now this voltage levels and connectors for this RS-232. Now initially RS-232 standard was established for interconnecting the equipment such as electromechanical teletypewriters. So teletypewriters, they were there in 1960s. So teletypewriters, modems and terminals and the mainframe computer. So these were the equipments which were interconnected. The standard defines electrical, mechanical and functional characteristics for interfacing communication equipment. So at that time, 1960, the equipment operated on high voltages and they used the negative true logic. So the voltage range minus 3 volts to minus 25 volts defines logic 1 or mark, and plus 3 volt to plus 25 volts defines logic 0 or space. Here the range between minus 3 to plus 3, it was on. So this is how the standard was specified in terms of voltage. Then the recommended connector type was called as the DB25. The miniature is having 25 pins and the signals are divided into 4 groups: data, control, timing and ground. So the connector type is called as the DB25. Let us see the modifications for use in PC. Now nowadays for serial communication in PC, the RS-232 standard is being used. That's why in order to make it suitable for PC, what are the changes required? We'll just see. So PC, it uses the TTL or CMOS logic level and plus 5 volt power supply, and the operating voltage in TTL or CMOS logic, they are less than 5 volt. Therefore these signals cannot be connected directly to the EI232 interface circuit. So in order to use this, we have to convert the negative logic and shift to the higher voltages by using line drive and line receiver. So combinedly they are called as the trans receiver. And this MAX 232A, that is the IC which is used for the line drivers and line receivers. So here you can see in the figure, we are trying to connect the DT to DC. So when we are connecting, this is the data terminal equipment, and the TTL level, it has to be converted to the EI or RS-232 level. So here we'll use the trans receiver, and this is the pin for transmit, pin number 2, and for receive we have pin number 3, and for ground pin number 7. So the voltages, they are converted. Plus 3.4 volt is converted to minus 9 volt, and 0.2 volts is converted to plus 9. So the range of the TTL and CMOS, it is converted to the range of the RS-232. So similarly here on this side for the DC, this will be receive, and again minus 9 volt will be converted to 3.4 volt. Similarly, plus 9 volt will be converted to 0.2 at the DC. So in this way, we'll need this line drivers and line receivers. So these are the line drivers and line receivers which are coming from this MAX 230 trans receiver. Then let us go further. Modifications for use in PC. The second problem, the PC serial communication is primarily asynchronous. Just now we have seen the types of serial communication, synchronous and asynchronous. So in case of PC, we use the asynchronous method. Therefore, the signals on DB25 connector which are used in the synchronous communications, they are not necessary for asynchronous. So only 7 to 9 signals are necessary. That's why the connector was changed to only 9 pins, which is known as DB9. So the 25 pin connector DB25 now is changed to 9 pins, so it is called as the DB9. So let us see this 25 pin and 9 pin connector with the associated signals. So here you can see, now this is the EI232 25 pin DB connector. So 1 to 13 on this side and then 14 to 25 on this side, and these are the various signals. Okay. Important is 2, that is the transmitted data TXD, and 3 received data, then request to send RTS, then clear to send CTS, data set ready DSR, then 7 signal ground, then other signals 8 carrier detect, then 9 10 these are reserved, then 11 is unsigned, 12, now 12 13 and 14, all these signals they are for the synchronous ring detect, indicator, data select, transmit clock. So that's why we are changing the 25 pin connector to 9 pin DB connector. So here we will be using a received line signal detect, then received data RxD, then transmitted data EXD, data terminal ready DTR, and clear to send CTS, request to send RTS, data set ready DSR, and ring indicator. Only these 9 pins are used for the asynchronous communication. Then let us go further. Transmission formats in asynchronous mode. Now we already discussed this. The transmission format has a typically start bit, then 7 or 8 bits data and a parity bit, and 1 or 2 stop bits. So here we have shown the format. The transmission begins with the start bit. So start bit will be always low, 0, and then we'll have the LSB B0, or in the previous case we have taken it as D0 to D7. So here it is B0 to B7. So in this figure we are showing the character Y9. This is character Y in ASCII. So Y9 we are showing. So if you look at this 0 1 0 1, so that if you are reading from this side to this side, we will get 0 1 0 1 5, and then 1 0 0 0 001, that is 959. So in this way the framing is done. So there is stop bit and a start bit. Stop bit will be 1, start bit will be 0. And here the baud rate is 9600 baud. So 1 upon 9600 you get 104 microseconds. So that will be the period of each of these period. So in this way the bits are framed, the character is framed, and then it will be transmitted, and the termination will be with the stop bit. It will end. So if you want, you can add the parity bit. So we have only 8 bits, so additional 1 bit, 9th bit will be parity bit. So in this way the transmission will be done with the help of different baud rates, and each character will be transmitted serially, one at a time, 1 bit at a time. So with this we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon, because without pressing the bell icon you will not get notifications about our future video. Now, as it will be difficult for you to search for different videos, it is better to press the bell icon and subscribe to our channel. Then thanks for watching. Have a nice day.